Well, I am so excited. We have Professor Mahesh Sharma with us today. He is such an amazing and prolific creator in the field of dyscalculia. We're thrilled to be talking to him today about sight facts, which we'll dig into more later. But I want to hear first from you. How did you get started in this field of study? What's your background?
Well, I'm a trained mathematician. I was faculty member at the university and later on the other positions of dean, provost, etc., etc. But by accidents, I got into education. In the late 60s, 67, 68, the Boston public schools were having an upheaval. The schools were being integrated. And as a result, there was upheaval in schools, particularly the teachers. Some of them did not want to, and the public did not want to welcome. And some of them wanted to, and at the same time, so both groups were militant about it. So a consortium was formed at MIT, and about 50 universities and colleges became part of that to help Boston public schools. And they asked for volunteers. And I was a young faculty member in my early 20s. And I volunteered to know, I was new to MIT. And so I became a volunteer to teach a class in Boston public schools. And I was assigned to a high school because I was coming from higher education. So they gave me a ninth grade class of poor performers. And but luckily, it was a very mixed class now because of this integration, and therefore I chose to do that. And I gave an equation, a simple one, and the equation was x plus 7 equals 11. And I asked a student, what is the answer to that? And I didn't ask them to write it on their paper. I said, just look at it and tell me the answer. There were 21 students. 4 of them counted 7, 8, 9, 10, 11. 1, 2, 3, 4, 5. That was new to me. 6 of them counted 8, 9, 10, 11, gave me the answer. At least they did the right thing. And the rest of them said, well, 4 plus 7 is 11, so x will be equal to 4. It was a shocking experience to me that 10 children out of 21, almost 50%, were counting on their fingers to get the answer for a simple fact, I will call it. I won't even call it a variable equation. So after the first day, I asked the headmaster to guide me so that I can go somewhere to find out why the children are coming to ninth grade not knowing their addition facts or subtraction facts for that matter. So they sent me to middle school, and there I found the same situation. Then they sent me to the superintendent, and superintendent said, what would you like to teach? I said, I want to know why they don't know addition and subtraction. I was new to America, to American education. So I new to school education. I mean, the only school experience I had was my own schooling. That's all. Yeah. So I'm sure he was a little annoyed with my request. So he thought, let me send him to kindergarten. And I think that'll be a good position for him. So I was sent to this kindergarten, and I appeared there. Now, I never knew what a kindergarten was because kindergarten was not a common thing in India at that time. And so here are these 5-year-olds. And now I come from a small village in India where we did not have phenomenal amount of these instructional materials and technology and all of those things. But one thing was common. We had playing cards.
Good.
So, and all children in my village knew their addition, subtraction, multiplication, division, even before we went to the school, because we were playing card games and we figured out the answers to things.
Right.
So I went to local drugstore after the first day, after I watched the kindergarten teacher teach them, and I got there were about 18 children in that kindergarten, so I bought 20 deck of cards, um, and they were nice, and I brought them and I gave. We are going to play games, and they are playing with these cards. Naturally, they like them. The only thing is that they look at the corner of the card,
Ah, yes,
and if you knew the number, they will know what was that, or they will
right.
count 1, 2, 3, 4, 5, 6, 7. Um, so I cut the corners so that the numbers will not be there. And they were now trying to count, but small numbers they will say, oh, that's a 2, that's a 5, that's a 4. And at that time, I joined a teachers training college where I had started a small lab school where I was working with Piagetian ideas. And I was looking at how number is conceptualized by children. And so this is a little later, but at that time, I did not know all of this. So I was just uh, finding my way out. But I found that up to 5 or 6, they learned that in no time. And later
Hmm.
on, further research shows that there is an innate concept called subitizing.
Yes.
And they were actually doing subitizing. And most of the children were able to actualize that innate ability by the help of cultural tool of cards
Hmm.
and the counting as a cultural tool also.
Right.
So the first thing in teaching children number or number concept, you talked about side facts. I'm giving
Mhm.
the origins of the
Yeah,
how
I love
side
it.
facts came about. So the child comes with two innate skills. One is subitizing, and the other is estimating small collection of objects. That is in the number domain, so to say, numeracy domain. But at the same time, children also have a sense of space.
Hmm.
And these are acquired very early on, few months, and by 2.5,
Right.
3 years, both of them are quite developed, and they are evolutionary concepts. A child, the man evolutionary needed to evaluate very quickly whether the predator group is bigger than us or
Right.
smaller than. If it's
Right.
bigger, we will run away. If it's smaller, we will stay. And
Yes.
I also have to look at who's on my right hand side, who's on my left hand side, who's behind me, and which way and what way we are going to attack or
Right.
fly away.
Yes,
So,
that's actually where the origin of our business name came from, is that every human walking the planet is wired for math. Everyone is made for math. So I love that you said that.
so with these three innate abilities, culture brings its own tools, and the tools are language, rituals, and usage of those rituals and language, and living uh, in a sense productively. That is the role of the culture. And to be productively living, they discover better and better and better and better tools.
Hmm.
And in acculturation, children are exposed to these tools, and those innate skills are realized.
Right.
When the culture has proper tools and the child has proper environment there, that actualization becomes facilitated better. And the child learns those things efficiently, early, and with competence. So
Hmm.
when they were playing with these cards, I saw no word at that time of subitizing in my mind, but they learned up to 5 or 6 very quickly.
Right.
After 5 or 6, I started working with them to relate what they already knew. And then I started also designing some new cards. So, for example, children were, this is a regular card from the deck of cards. They were able to see the 5 and 5 very quickly. But it was very difficult for them to see all other combinations of 10.
Right.
So I designed a new card and I said, okay, there is a 5 and 5 easily. And then I will say, tell me, how many are there? First, I'll say, how many are there? Oh, 4. So there are some hiding. And I will have this card displayed. And they say, oh, yeah, there are many more hiding. And some will take a guess and on all that. Then I'll say, 2? No, more than 2. 4? No, more than 4. That many? Yes. So 4 and what is 10? 6. 4 and 6 is 10. Now notice they realize that 4 and 6 is 10, not by account, but by sight.
Right.
So then I will say, oh, all right, so let's see. How many are on the second column? 5. How many are on the first column? 5. So 5 and 5 is how much? 10. Oh, 5 can be this way and 5 can be that way. It's still 5 and 5. I said, good. So that was helpful, this addition of this card. Then I found that children were able to, so now I wanted to take this, I wanted to see what should we do so that they will realize other combinations of 10 also. So for that we started. So I said, let's start with 7 because 6 was easy for them. They could really, give all the combinations of 6 very easily, combinations of 5 easily. It was 7, 8, 9, and 10.
Yeah.
These were the 4 numbers which were difficult. So I started working with 7 first. So here is so I asked them, here is my 6, and you already know all of them. And here is a number I'm putting in front of you. And tell me, how do I make that 6 into this number? And naturally, somebody said it's a 7. And you need to put a 1 here. And there'll be 7.
Oh, I love it.
Can I put it here? So yeah, you can put it here. Can I put it here? Yeah, you can put it anywhere you want to. Can I put it here? Yes, you can. But that's really cute. That's really neat.
Yes.
That's children's words. They will say, that is better. That's why that is there. I said, is it still 7? Oh, yeah, it's still 7. And there comes the conservation of number, Piagetian idea. And is it 7? Yeah, it's 7. I'll make that 7 right here. That's the same 7. And what if I have this 7? And they will say, well, actually, I could have put that in the first place. And therefore, that is 7. So then I said, oh, that's good. So 6 and 1 is 7. And 1 and 6 is 7. Yes. So then I said, tell me, I have this number in my hand. I want to share with you. Tell me, do you see that 5 on that 7 card? Yeah, it's right there. And somebody will say, oh, 5 and 2 is 7 without my prompting. Then others will say, yeah, 5 and 2 is 7. And somebody will say 2 and 5 is 7. So that's good. The only problem was, how do I make 4 and 3 equals 7? Because in the regular deck of cards, the 3 was this. And if I put this one here, it was not that easy. So I decided I'm going to create a new card. And I created this card. And they instantly said, that's a 3. That's a nice 3. And see, there's a triangle there. And all of these things children get excited about, they discover. And I said to them, do you see that number? So, oh, yeah, that's a 3. And now, do you see that number? And so they said, yeah. So tell me what 2 numbers will make 7. Say 4 and 3. So now they know 5 and 2, 2 and 5, 6 and 1, 1 and 6, 3 and 4, 4 and 3. We have all the side facts of 7. Now, why the name side facts? So I want to take a little digression there.
Yes, please share. That was going to be my next question.
Yeah. To be a reading, for a child to become competent reader, there are I mean, I'm oversimplifying, but people know that that's a little oversimplification to take an analogy.
Right.
5 things are necessary for a child to acquire. The first one is the child must have good understanding of the alphabet.
Mhm.
The second, the child must have good sight vocabulary. Underline sight vocabulary. How does one learn sight vocabulary? By exposure, 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 sight.
Yes.
Third, the child should have phonemic awareness, phonological sensitivity. When these 3 things are there, and when you give a new word, by the help of sight words and phonemic awareness, the child begins to chunk and blend, chunk and blend. That means the child acquires word attack skills.
Right.
Then we need a 5th thing. So first is the alphabet, second is the sight vocabulary, third is phonemic awareness, fourth is word attack skills, fifth is a sympathetic, knowledgeable adult who will practice these 4 skills with that child and practice blending and chunking and blending, chunking and blending. And the child becomes a competent and asks tons of questions. That's where the knowledgeable, sympathetic adult's role comes into play. And I find the parents trained in that are the best teachers rather than teachers.
Right.
Because they have empathy, they have sympathy, they can practice 2,900 times.
Right.
In a workshop, a teacher asked me, how long should I practice the sight words, sight facts? I said, do you have a child? He said, yeah. How old is he? 4 years old. At one time, he was 9 months old. Yeah. How many times he fell down? Oh, thousands of times. What did you do when he fell down? Get up and let fall down more.
Yeah, right.
Did it come to your mind that enough practice now and I should get a wheelchair for this child? Of course not. What are you talking about? I said, why do you ask how much should he practice? Practice till he has learned it.
Right.
So a parent can do that and a teacher will count. I have tried. 80% mastery is good enough for me, but not for a parent, So when I see the IT writing, that 80% mastery of facts is good enough, I say, yeah, sure. You don't are taking from your child's perspective. It's somebody else's child, So that is necessary. Now, the same 5 things are necessary for numeracy or learning number concept. First, I must know my alphabets. And there are only 10 items in the alphabet of mathematics. Those are the 10 digits, 0, 1, 2, 3, 4, 5, 9. Number 2, I must have something like sight words. And that's where the sight facts come into play. Now, it's coincidence that there are 43 to 45 phonemes in English language, and there are 45 sight facts for numbers up to 10. So it's not an accident. That's how the term sight facts came. And so sight facts must be done really, and they must be done by this, not by, break this one and count this one and count this one. And, this is 5 and that is 2 and that is 3, count this one. See, that's counting. That's not sight facts.
Yes.
Third is parallel to phonemic awareness, decomposition, recomposition. 7 is made up of 5 and 2. It's made up of 3 and 4. You see, these are like the phoneme. You are breaking that into phonemic components, the smallest component of sound. Here we are making into smallest component of those digits. The digit 2, digit 3. I'm looking for the 2 there. I'm looking for 3 there. I'm looking for 4 there. I'm looking for 5 there. So decomposition, recomposition is to numeracy as phonemic awareness is to literacy.
Right.
By the help of this decomposition, recomposition, by sight facts, the child learns number attack skills. I want to add 8 plus 7. How do I make 8 into 10? That's a sight facts. 2 more. Where is the 2 coming from? 7. And what is left? 5. Notice in both cases, sight fact is being used. Then I say 8 plus 2 is what? 10. And 10 plus 5 is what? 15. So to be fluent in facts, one should know 45 side facts, making 10, teens numbers, and decomposition, recomposition, and the child is on his way to conquering the world. Because
Yes.
the three components which are affected by dyscalculia are number concept, concept of number, number relationships, and outcomes of numerical operations. So once you understand what is affected, what can be done, so the solution to a child who has dyscalculia or has acquired dyscalculia, so I coined a term called acquired dyscalculia. Acquired dyscalculia means there is no problem with the child.
Mm-hmm.
It's not in the child. Dyscalculia might have some innate factors. There might be visual perceptual deficit, or there might be some neurological reasons. There might be abnormality in the architect of the brain. There might be other factors. But acquired dyscalculia means the instrument is intact, but it
Right.
was not properly used.
I
I mean, the
like that.
child comes to kindergarten and count and count and count and count, and they become bean counters, very competent bean counters, but they don't become number operators,
Right.
So number concept is the basis of really how to deal with dyscalculia. So that's how these visual cluster cards came into existence. Then, so the child can practice by himself or herself, there's a second set of cards, and they are called sight fact cards, where the decomposition of numbers is already marked, and therefore the child says, oh, 5 and 3 is 8, or
Yeah.
6 and 2 is 8. So these are called visual cluster cards, teaching cards, and then you can practice by many other ways, Cuisenaire rods, and so on and so forth.
Right. And I
That's
saw
really,
these for sale on your website, right? So I'll make sure to
oh
link
yeah,
those
yeah.
up.
Or people can go, send an email to my center,
Mhm.
and then yeah, they are available. Yeah.
Yeah, I love that. So one thing
As
I'm
a
wondering, I can hear
there is
teachers chattering in my head.
yeah
So,
there is an ebook I wrote called Number Concept,
okay,
and that in that book I have talked about all of this what I just talked about, uh,
awesome. I'll make
and
sure to link to
theoretical,
that too.
yeah, theoretical
Wonderful.
framework also. Yeah,
So
yeah.
I'm wondering about as far as like expected time it can take a student to learn these site facts. I know that repetition matters, but we also know there's homes where students are not going to get the parental
No,
support to do
no
it. So what would
child,
you recommend?
no child should leave kindergarten without mastering sight facts.
Mm-hmm.
Just like our expectations of number of sight words varies anywhere from a school of 30 sight words to 100 sight words, 120 sight words. You see, your levels, your expectations of children decide,
Mm-hmm.
how many sight words will they have,
Mm-hmm.
what background, etc., etc. But, I strongly believe, and I've seen it and I've done it, and many of our teachers we have trained have done it, that the 45 side facts, making 10, teens numbers, decomposition, recomposition is easily learned by children. We are working with 2.5 and 3-year-olds. And there are 3-year-olds and 4-year-olds now are giving me side facts as fast as I would like them to give.
That's amazing.
So from 2.5 to 3-year-olds, we can begin that decomposition, recomposition, realizing, summatizing, counting, and all the integration of these creates that number concept.
Sure. And so the other thing I'm wondering with your site facts and your cards, at what point do you start introducing like a Cuisenaire rod or some other kind of manipulative?
Actually, I will introduce them very early on. As a matter of fact, suppose I am introducing the number 4, then I'll ask a child to create that cluster card. So here is the 4, and then I'll say, that's good. Can I put them in a line? And let's see if any rod of here will fit here. Naturally, as soon as you do that, then they want to experiment with each one of them. and the Cuisenaire rods are introduced.
Mm-hmm.
And there are two videos I put on YouTube. They are free.
Okay.
People can watch them, because
Sure.
my goal is that no child should be having problems in number conceptualization.
Right.
Therefore, those free videos are there on YouTube. The title is something like Math Lessons with Professor Sharma or something like that.
Yeah. We'll
And
link up to them.
those two ebooks, one is on the questioning process, because that is what the role of teacher in my method of teaching is. The approach is called CPVA, concrete, pictorial, visualization, and abstract.
Mm-hmm.
So the pattern, concrete pictures, that brain processes faster. Then you must visualize that in your working memory.
Right.
Oh, the 7, 5 and 2, 3 and 4, 4 and 3. And the cards facilitate that visualization. And then abstract, yeah, write them down. Oh, yeah, 1 plus 6 is 7. I mean, children go to writing so quickly. My criteria is that you give me the side effects of 7 orally, fast, and if they are all correct and they are all in order, you are free to write them. And
That's
they
great.
want to write every number. So they will come to me and tell me, I have 8. Can I
Mm-hmm.
write all the 8 facts? Can I write 9? Sure, go ahead.
That's
And
great. I love that. And the other thing I was wondering about is playing games with your site fact cards. Do you ever have fun games that you like to
yeah,
do with
I mean,
students?
for example, there is a booklet I designed for parents called Games and Their Uses.
Mm-hmm.
And there are games with the visual cluster cards. So, for example, I might say, well, these are your cards. We are playing addition game. And these are, I'm going to take, for this purpose, these are my cards. So tell me who's winning.
Mm-hmm.
Oh, you are winning because that and that together is 8. Oh, no, we have the same number.
Mm-hmm.
And it's, oh, it's 8 plus 2, 10 and 10. Good. Then I say, okay, since we are competing, I'm going to put 2 more cards. And whosoever is the winner now is going to take all of these cards. And at
Right.
the end, whoever has more cards is the winner. Said that is beating this, that is same. So I'm winning by 6 there. Oh, I'm winning by 3. Notice what did they do? They
Mm-hmm.
actually came to decomposition, recomposition by themselves. So
Yeah.
yeah, playing tons of
Yes.
games like that. Yeah.
I love that. Thank you for sharing that with us.
Yeah.
The other thing I just wanted to draw attention to is that on Tuesday mornings around 8 a.m. Eastern, I
It's
think you do a
exactly at
lot of free
8 a.m.
trainings.
Yeah, this is a free webinar I give to teachers and parents, and I begin every year. I've been running it for many years. It begins sometime in August with number concept, and all the way back to August, I finish it in algebra. And I
Mm-hmm.
take a whole curriculum from pre-kindergarten to all the way to algebra.
I love
Uh,
that.
yeah, so people can join anytime they want to, and any grade level interest they have. Some of them stay the whole year. As a matter of fact, some of them are there for several years, and
Mm-hmm.
they just keep on coming.
Keep practicing. I love that. I think that's such a great resource, and thank you for providing that for people. So my final question for you is, what's next? What else are you hoping to accomplish? You are a go-getter.
Well, my belief is that when you are able to change one teacher, you have you have affected 1,000 children in the teaching career. So every webinar Tuesdays I give or lecture I give, and if I send one teacher who says I'm going to do it, I consider that a success.
Yes.
Luckily, more than one teacher goes with that. So I really want children to feel liking math, loving math, and feeling that it's within my reach to do that.
Yeah.
Otherwise, socially and otherwise, math has become such a big negative reaction. People have such. I go to parties and they will say, "What do you do?" Even when I was president of an institution, I used to say, "I teach math." And as soon as I teach math, they will say, oh, well, I was never a math person. I'm a creative person. I say, wait a minute. Do you mean to say the mathematicians are not creative? Uh, they, oh, no, no, mathematicians, they have a particular image. I said, no, no, they can laugh, they can joke, they can also do all of these things. So I want to create an image so that, it's not seen as oh, I hate math.
Yes,
No child is born saying, I hate math.
right.
They come to school and they start saying, I hate math. So it is an infectious disease schools give.
Yeah.
It
I
is
love that.
it is iatrogenic disease. There are people who go to hospital and they come out with an extra disease which they didn't have before they went in. Those are called iatrogenic diseases. Well,
Mhm.
math anxiety in children is an iatrogenic disease. We have given it to them.
Yes.
They
Oh, I'm
didn't
so
come.
glad you said that. Yes,
Yeah.
I agree. Um,
So I
because you
need to
said it,
go.
that mathematicians can be funny. Do you know any puns or jokes that you want to share that are math based?
No. uh, Jokes are always contextual.
Yes, they are.
Yeah. Yeah.
Awesome.
Yeah, yeah. But if you are dyslexic, you might read dog as God and God is dog. And you might even see God not one, but many. And then there is a problem. Which one should I bow to?
Yeah, yeah. I love it. Oh, Professor Sharma, it was so good to have you today. Thanks for being with us.
My pleasure. My pleasure.